Recently, the word DeepSeek is getting very popular. The reason why? Because of its innovation it made, and also that it is able to achieve the GPT's performance, and the model was being open sourced by the DeepSeek. So that was like blown up a lot of tech giants' minds and everything, right? Because of that, uh, the companies like Nvidia, Google, their stocks also decreased or they crashed, we can in one way, right? So being said that, right, of course everybody is talking about the DeepSeek, but if you are a AI aspirant or if you want to become a data scientist, right, you should able to understand the technical details of how DeepSeek was made and what is the innovation. You should be able to understand how the model was built and all the technical details about the DeepSeek. So for that, actually, we need to understand how this DeepSeek R1 was built. So this is the paper, by the way, that's been published by the DeepSeek. So in this video, I'm gonna try to explain like how this DeepSeek was built and the technical details about it. Of course, yeah, right. If you see this math equation as well, this looks like very, I mean, it looks very hard and it's look like very dry subject, right? But in this video, I'm very sure if you follow this video or the series of this particular video, you should be able to understand how this math was formed and I mean, what's the intuition behind this formula and all. So I recommend you to watch this complete series till end. Yeah, without moving forward, right? This video I want to put it in two parts, part number one and part number two. So the part number one, because see, the the things that I want to cover, that cannot be end up with a lot of things I need to cover. So I thought of like setting this part one, limiting to the basics that are required to understand the DeepSeek. So the part one will be majorly focused on the basics and the prerequisites to understand the DeepSeek. And the part two, we will in detail we can talk about the DeepSeek. Right? We're gonna dive deep into the DeepSeek and we're gonna talk a lot about the DeepSeek. So as this video is scoped for part one, let's get started. So about the basics, right? I should have written somewhere, right? Yeah, then part one, we're gonna start. So what are the model that you are consider, right? Be it AI model or ML model or LLM, what are the terminology you are aware with? So all the generic word is called model, right? The model will accept the input and it knows how to generate the output, right? For a given input. How it knows? Because this model or any LLM, okay, it will be trained with billions of data. What the data contains? The data contains input and the output. And the input and the output samples could be millions and trillions sometimes maybe. So that kind of examples it will have, that these kind of points or the samples will be trained to the model. If it is a LLM, right, mostly the LLMs like GPT or or Mixtral or the Llama, right? Llama, these kind of models were trained on massively data that is widely available in the internet, right? So these models knows for a given input what to generate, right? That was trained in such a way, right? This we called as, once the model is trained, we call that as a pre-trained model. Pre-trained model. If you consider the case for the LLM, this pre-training will happen by considering the data that is mostly available in the internet. So right, from the internet it will try to collect the data and they're gonna train it, right? So once this is pre-trained, there is a very important mechanism that is required here. Model will give the output, but this output might not be readable or might not be feasible for all the end users. Of course, if you are from a tech background, you should be able to understand certain points. If you are from law background, you will easily able to understand the, I mean, if the query is about the law and all, you will easily understand like the output that is given by the GPT or whatever, right? But for a layman, it's very much important that certain things should be followed, that should helpful for any human to understand whatever the output that's being generated by the pre-trained model, right? It will give the output, but we don't know like this output is being you know being interested, I mean, it's been friendly for the user. Okay, this output, sometimes the output might not, most of the times the output might not be human preferable way. So no matter, I mean, let's see, if you if you're gonna build any application or anything, that should be as much as user friendly as possible, right? So here also we're gonna do the same. The output generation is important, but the generated output should be readable by the human. Another way, it should be readable by the layman. Okay, so to do that, what we have to do is, I mean, so far we are good with if the pre-trained model, if the model is pre-trained, what are the input we are giving, the model knows what to generate as a output for a given input, right? This will be sorted once the pre-training is done. But now comes the interesting part. So what are the output this is gonna generate that should be preferable by the human? I mean, that should be easily readable by the human. So to address this problem, what typically companies who trains the LLMs or the models, what they will do, they're gonna try, they're gonna give one input, let's say the input or the query. For a given query, they're gonna generate different outputs: output 1, output 2, output 3, and output 4, right? So in these outputs, there will be a human or someone, human human or humans, to be precise, humans who will rank these outputs based on the relevance. Let's say output is more relevant and most I mean, most close to the what human is preferring, that will be ranked as number one. And if the O4 is least, or I mean, if the O4 is much more you know like you know in terms of readability and all, if it aligns to the query as well as the human readability, this will be ranked number one. Accordingly, all the outputs that are generated at the time will be ranked accordingly by the humans, right? For every query, out of 10 or 20 generated outputs or 5 to 6 generated outputs, they're going to rank it and they're going to give some marks. Like if the output 1 is much more promising, they're going to give max marks to the output 1, and they're going to give the least marks to the least output. If it is there, I can show you an example. Yeah, it's here. See, for example, if the query is like this, okay, let me change my color, it is not displaying here. Okay, if this is the query, right? If this is a query given to the LLM or any model, it gives the output like this. Okay, set of outputs: output 1, output 2, output 3, output 4. And if you see, out of all these outputs, this is the best output, right? That's why this is ranked as number one. Okay, and if you see the worst output, this is not at all, this is the worst output. Why? Because this is factually incorrect. If you see what is the question, it is what is the capital of France, right? So this France capital is basically, it's a Paris, right? That's why we have given the first preference here, and it is giving some other city or which is not even relevant here. So that's why you're giving the incorrect, I mean, the least ranking we have given, fourth rank we have given, right? And there are also similar responses. The capital of France is Paris, city in Europe. This is also desired output, I mean, agreeable up to the point, but the city of Europe and all, there is kind of extra information that what we don't require. So for that reason, might be we can give as a second rank here. Similarly, if you see what is the capital of France, Paris is the correct answer, but still it's a very short, it's not, I mean, it's not, it does not even have a minimum rationale, right? So this is not much more readable and much more not preferable to the human, right? That's why we have given the third rank, right? Similarly, for every query, right? For every query, I mean, once it is there in the production, right? Once it is the pre-trained model, or I mean before production also, for every query, right, we're gonna have these kind of rankings, and that query, right, Q1 and question number 1 and the preferred outputs. We don't, sometimes we only prefer two outputs, the rank, the most ranked is O1 and the next best ranked is O4, let's say example, and we're gonna consider these two, and we don't gonna consider the rest of the things. And for question 2 by some other user, right, or by some other query, we do have this kind of outputs, and we're gonna rank them like this. O3 might be the best one and O2 might be the second best one, something like that. And these rank, according to the ranks also, some of the marks or some scores can be awarded, right? Who does these labels? Human or the SMEs. SMEs, subject matter expert in that particular area. If the query is about mathematics, and the mathematics person should be able to reward this kind of ranks, right? So if the question is about science, some person who are very well good in science and all, is the correct person to rank this. So there is a human effort involved here once this ranking is done, right? Once this ranking is done, okay, once this ranking is done for certain, like 10,000 samples or 20,000 samples or any, I mean, some massive amount of ranking is done, this kind of information can be feedback to the base model, right? This kind of data we have, right? This kind of data that we're gonna feedback to the model. This is a base model, right? LLM. Okay, this is not LLM. The most generic term is a model. Okay, model that can be a DL or ML. Sometimes nowadays it's an LLM, right? So whatever the model that already pre-trained, that can be adjusted or updated the learning based on this preferable outputs, right? This entire thing, right? This entire framework is called reinforcement learning. So the model will automatically learn by the human provided or human labeled data, right? This will happen automatically. I mean, the learning will happen automatically, but the labeling has to done manually by the humans, right? So there we have I mean, this is what we call as a basic reinforcement learning architecture or the reinforcement learning framework, right? Let's say without human, right? Without human, of course, with the human, right, we do require the human support for initially. Let's say after 10,000 samples or the 20,000 samples, or let's say some massive amount of data that is being trained, that's been labeled by the humans. Yeah, of course, yeah, humans are the best ones to label or rank the data. Companies like Google, right? Google or even Meta hire some of the third-party companies to label the data itself, to label or rank the data. They hire some many companies, third-party companies in India basically, to label the data, right? Once they label the data, right, they're going to use it for reinforcement learning or pre-training. We don't know, right? So yeah, coming back to the point, right? Once the data is labeled by humans, let's say if I train a model something like this, another model I'm talking about, new model. If I train a model like this, right, for a given set of inputs, let's say I'm giving 10 inputs, give me the ranks automatically. Give me the ranks, right? So let's say these inputs are output from the pre-trained model. Inputs for this model are outputs from the pre-trained model, right? Once we have given these outputs, this particular model what we have trained with this 20,000 data or 10,000 data should automatically learns how to rank these particular outputs, right? So this will happen because we already trained one of the model. We already have this labeled data. With this labeled data we can train one more model, right? One more LLM, or else most generic way, one more model we can train. So this model will always gives the ranking based on the human mindset. Let's say O3 is rank 1, or O3 has 90% of reward, or something like that. I'm just trying to explain the intuitiveness. There could be n number of possible cases, or they're gonna spend, I mean, there could be n number of, if you zoom in it, there will be like a lot of technicality involved here, but I'm just giving the high level overview. Hope you get it, right? O4 is rank 2 and it is with 80%, and something like that. 80 or 90 is something like a rewards. Okay, so so the human involvement will be greatly reduced here. So finally the model, how it look like is, right? So this model, of course, this model with the human feedback, right? This is a human feedback. With the human feedback, we call this as a reinforcement learning with human feedback. Reinforcement learning with the human feedback. Okay, and now once the model, once the model is trained with the human labeled data, there is no need to label the data by the humans going forward for this particular case, right? There, instead of humans, we're gonna directly use this trained model in place of the humans here, right? Yes, coming back to here, right? Now the updata structure will be like this. This is the LLM, this is the model, that could be ML or DL model. Mostly it will be a DL model or ML model. Input, input can be a query, right? Query, something like what is the capital of France, something like that, and it's gonna generate the output, set of outputs. Here there is a one more reward model that will model. I can call it as a reward model. Of course, there are, you know, too much of mechanisms could be there in real time, but I'm just giving a high level overview. For now, you can think it of like this is a reward model, which will give the scores for the set of outputs that are generated by the pre-trained model. This is a pre-trained model, right? Pre-trained. Let me change the color. This red looks very, scary. So yeah, once this reward model is done, there should be another block, RL block, reinforcement learning block, which will responsible for updating the weights or updating the parameters that are there in this base model. See, the thing is that this is a feedback layer, right? This update should not happen, I mean, because of this multiple iterations, right? Updates should not corrupt the original learning of the model. The updating should always happen in a very controlled way. To control that, there should be another algorithm should be put in place here, so that it should update the new learnings strategically without corrupting the original learnings that model has done. Because see, the original learning was done on very massive amount of data. It knows the logics and everything, but what it don't know at this point, you don't know human preferable outputs, right? We are just teach the model how human wants to see the output, that human preferable language. For that, there should be a control feedback mechanism should be there. So that is where the whole magic involves here, this control feedback, right? So that I'm gonna try to explain bit. I mean, there could be a number of techniques here, by the way. There could be a number of techniques, but now in this video we require to know this PPO to understand the reinforcement in DeepSeek. Let's talk about PPO. Currently one of the reinforcement algorithm that which will control, which will control model reinforcement learning without corrupting the basic structure or the basic foundational learning of that particular model, right? So yeah, how PPO works in the sense, let's say the initial pass, right? Initial pass without this reward model and all, right? One in the day one, let's say the query passes here, right? The output will be coming from the model, right? All the outputs, let's say the set of outputs, 4 outputs are coming from this model, and this model will reward that particular model outputs, and it gonna update. It needs to update the pre-trained model. How it gonna update in the sense, let's say the new model, let's say the current model, we call it as an old model. Why? Because let's consider that one iteration is completed. Okay, by the way, this can be entirely productionized. It can be run in the production as well. Think of it like, I don't know, ChatGPT and all doing this, but theoretically it can happen, right? So whenever the user, being a user, I will create a query, and for me it shows one query, but in backend it might generate a number of queries. Those queries can be rewarded using the reward models, and there should be a feedback mechanism to tell that out of all these 10 samples, out of all these 10 examples that you have generated, 10 outputs that you have generated, only 2 of them are really good, rest of them you can ignore when someone asks the same question again, similar question again. That kind of feedback mechanism will be there in the production also, so that the model will evolve as days passes, right? This could be there in production also. Okay, so yeah, now coming back to the point again, the PPO. What PPO means? Proximity. I forgot to write it down. Proximity policy optimization. Proximity policy optimization. What does it mean? Whenever the model uh, gives the output, right? So the input is Q1, output is O1, right? So for a given question or the query is something like, what is the capital of France? right? What is the capital of France, or any question that you ask of the chat GPT, you can think of that manner. For a given question, what is the probability of generating that output O1? Okay, this is the probability. So once one iteration is done, right? One iteration is done in the sense old model and new model will be there, right? Old model is the one before the update was happened, before this particular feedback mechanism was happened, and new model is the one where one iteration, one iteration, once the one iteration is completed, one update might happen, right? So we're gonna check like what is the probability of in a old, I mean in a previous state of the model, what is the probability of generating the output one for a given question A, and we can also measure what is the probability of new model. Probability is nothing, this conditional probability is nothing but the conditional probability that we have studied in our plus 2 or graduation. This is the same probability, but in the paper and all they are using the pi instead of the p. That's why I'm also using the pi here. So yeah, this is the old one and this is the current one, current model, in the sense new model. And for a given query q, what is the output of, what is the probability of generating that particular question, that particular output is the O1. Okay, I'll tell an example again. Let's come back here. Let's say the query is like this, right? Initially at first pass the model has generated this particular output, let's say the Paris. Okay, so the model has generated the Paris without update, right? Without update in the sense the old model. Okay, before having the update. So what is the probability? This is the query is this France. For a given query, what is the probability of generating the O1 here? In the sense there can be one probability, because the probability often of course the models or whatever the ML or DL model are like probabilistic in nature. It's like a rolling a dice, and we might not know. Just now it gives the 6, and after you repeat that experiment again, there is no guarantee that 6 will come again, right? It can be 3 or 4 or 5 or something like that. There is always a probability calculation behind that. Similarly, can be a randomness. There could be a randomness in the experiment. So because of that randomness, there should be a probability. Whenever the randomness is there, we should be able to calculate the probability, right? So that is where for a given query, what should be the output from the old model? We should be able to calculate that, and same for the current model. In the new model, we should be able to calculate what is the probability of output O1, generating output O1 for a given query. So once after these two are calculated, what we can do is we have to take the ratio of these two. Okay, that ratio we call it as, ratio will be like this. For simplicity I will write new and write old, whereas new I am referring to this particular probability and old I am referring to this particular probability. So that will be, we call it as, we are denoted with R of data, and this we call it as what we call sampling ratio. Call it a sampling ratio of importance, or sampling ratio of importance, or importance sampling ratio. So let's try to get the intuition from this particular equation. Let's say the old model not able to generate or replicate, right? Not able to replicate the same response, same O1 response when the same question Q is asked. Okay, if it is not able to generate it, the probability will be 0, right? So this one I'm talking about. If it is not able to generate the same output O1 for a given Q1, the probability will be 0. Is it? This is a case 1, by the way. The probability will be 0. And let's say the new model is generating the output of Q1 with very low probability, like 0.3 or something like that. Then R of theta, what it will happen? It will be infinity, right? Number divided by 0 is infinity or undefined, whatever. So this is a case 1 I'll talk about. And the case 2, in the sense, case 2, let's say the model, right, the old model is able to generate the same output again with the 0.8 probability, and the new model is not able to generate it, not able to generate the same output O1 for a after update, right? New one is the after update it is not able to generate the O1, which means it is totally forget what it is learned. I mean the base model totally forget if it is not able to generate, in the sense that when the probability is zero, in the sense the LLM, the pre-trained LLM with the recent update, it forgets what to generate when this kind of input is coming. Do you agree with that? When I'll repeat it again. With the recent output, with the recent feedback, what it forgets? It forgets what to generate. It completely forgets what to generate if the same input is given. So in that case only, the probability of new one will be zero. Do you agree on that? So if that is the case, R of theta value will be zero, right? R of theta value will be zero. So whenever this zero is there, what we have to do, whenever the R of theta is zero, what we have to do, we have to reject that update cycle. Did you get it? We have to reject. I'll come to this. What happens at the infinity level? Whenever the R of theta is zero, we have to reject that particular update cycle. Why? Because of this zero, in the sense, with this the recent update, the model is forgetting what it is learned from base learning. I mean, it's a basic learning, it's forgetting. So that kind of updates are harmful for the model, right? That kind of updates are harmful for the model. So whenever the R of theta is zero, we have to reject that kind of update. That iteration we should not update. Okay, not update the weights. So this is whenever new model is giving the zero probability. What if the old model itself is giving zero probability, but new model is giving some probability? In the sense, what it means is it has some valid information. Because of that, of course, the old model is not able to generate it the same question. If the what zero means here, if I ask the same question to the old model, I mean old model in the sense, when the feedback is not applied, right? If the old model, if I ask the same question of the old model multiple times, it is not generating the same output. But with this update, right, with the reward mark update, it is generating something, right? It is generating something. That's why the values goes beyond the infinity. So always understand the theoretical value of R of theta can be vary between, that can we start between 0 to infinity, right? 0 to infinity. This is a theoretical value, but and see, this is a theoretical value, right? The infinity, in the sense, whatever, understand one more thing here, we talked about whatever the update we are doing here, that should be in a controlled way. We mentioned it here, right? That should be, whatever the update we are doing, that should be happen in a very controlled way. If the update, if it is varies till the infinity, understand, if the R of theta value can be 1000, theoretically possible, 10,000, anything like massive number is also possible for R of theta. If you are updating this much of information to the base learner model, it will learn then what it is required. Okay, it will learn then what it is required, and it might try to hallucinate, and it create other issues. So whatever the values that we are updating, it should be in a very controlled manner. So we have to use some clipping mechanism here. Clipping mechanism in the sense, putting the R of theta value or whatever the update value in a certain threshold. It should not cross beyond some limit, right? It should not cross beyond some limit, right? Whatever the R of theta, be it, let's say R of theta is 1, it's fine. If R of theta is 1000, we should not update the value with 1000. We should clip it to something like 2 point or something. Whatever the theta value, R of theta value exceeding this 2 point something, we should still consider it as a 2.5 as a max value. In that way we have to handle it. How to handle it? There is a clipping concept, is called clipping mechanism. We can use that. Let me write a equation for that. Right, before writing an equation, I'll write like this: R of theta, right? Always, I mean theoretically it starts from 0 and it can end with any value. There is no limit on it. So right, so R of theta should not exceed certain limit. That limit can be, I can call it as some x. It should not cross the certain limit. That particular limit we can call it as x, and this can be controlled with, I mean, in the equation also they mention it with 1 plus epsilon. Okay, this is the max value of r of theta that should not cross. Here the epsilon typically we use like 0.2. So if I substitute that, r of theta max value will be 1 plus 0.2, which is 1.2, right? Whatever the value we coming it, if it is crosses beyond 1.2, we still consider as a 1.2. Okay, and then for minimum also, I mean, yeah, minimum we'll talk about it, and right, minimum is 0, right? So yeah, this will be handled with the clip function. There is a clip function. I'm gonna write it down, r of theta, and the max value is epsilon, 1 plus epsilon and 1 minus epsilon. Okay, why epsilon we are introducing it here? Epsilon can be a small number. Typically epsilon value is 0.2, and this can be used as a hyperparameter whenever you are fine tuning your RL mechanism into your model, right? This can be used as a hyperparameter. Okay, so r of theta 1 plus c and 1 plus epsilon. What happens is, for example, this is a max value and this is a min value. So if the r of theta is 0.5, right? So what happens, did it cross 1.2? No, right? This value is 1.2. It is not crossed the 1.2. But what is 1 minus 0.2 is 0.8, right? So did it cross the minimum value? Yes, it crossed. The minimum value should be 0.8, but here the 0.5 is there. So the clip will give like 0.8, right? Because what we are saying with the clip function, what are the value are coming, that should be always in between the 1.2 or 1.2 whenever the epsilon is 0.2. Is that so? So with being said that, this is about the clip function. We are not talking about which value to consider. This is a clip function. So the final objective function will be something like this: r of theta, minimum of r of theta, minimum from this one, or the clip of entire this thing, clip of r of theta 1 plus epsilon. 1 plus epsilon is the maximum value, 1 minus epsilon is the minimum value. Okay, and minimum of this, and there should be a one more parameter is there called AI. A is a advantage learning. We'll talk about more when we are talking about DeepSeek. Minimum of this and minimum number of this will be a controlling factor to the PPO algorithm. This is the overall objective function for PPO. I think I have started explaining things here, right? This is all about PPO. Did I write somewhere? Yeah, PPO, proximity policy optimization. So the proximity policy optimization starts with calculating the probability of generating the same output with the new update and probability of generating the same output for a given question with the old output. With this ratio will be considered like this. I mean, that control number, understand this thing, right? Whatever the number it's coming, we should not blindly pass it, right? The reason is, whatever the updates we are doing, that should be in a very controlled manner, not like directly, even though it's a number is big and small, we don't blindly do that. The update should happen very sensible way and very controllable way. That control will happen with the PPO, one of the algorithm, and this is the objective function for that PPO. All right, let me write it down here again. So minimum of, this is a big bracket, minimum of r of theta and clip r of theta, and this is a small function inside the minimum, clip of r of theta 1 minus epsilon and 1 plus epsilon, right? Let's say that r of theta, we will calculate it. Okay, how it happens, right? Let's say the new divided by old, right? Old. So if, for example, say the probability of new is like 0.6 and the volt is 0.3, how much it will be? 0.2? No, my bad, it's not 0.2, it's 2, right? It's 2 because the point and point will cut and it's 2. The r of theta will be 2. So 2 in the sense is a very huge number in the magnitude, right? This much of update if you are doing for one iteration, in the sense it gonna affect a lot of parameters in the base model, right? So before directly passing the 2, what we're gonna do is, of course, there is a advantage number here. Advantage number, like I said, advantage number multiplication will be here. So what will happen? This will go to this function. R of theta is how much? It is 2 into a advantage number. We'll talk about in detail. For now, just think of like, this is a degree of how much the current model is deviated from the base model. From the base model in the sense where the RL is not at all started. Okay. And clip in the sense, clip R of theta is 2, and the epsilon is a hyperparameter, but for now assume it like a 0.2. Okay, 0.2 in the sense 1 minus 0.2, 0.8, 0.8, and 1 plus 2, sorry, 1 plus 0.2 is 1.2, right, into the number. So this 2 is not less than 0.8, right? So obviously 0.8 will not be selected, but this 2, clip, this 2 is greater than the 1.2. So the output from the clip function will be 1.2. 1.2 into this factor I'm writing it here, a, right? And what will be the minimum now? Minimum is minimum of 2 into a or 1.2 into a. 1.2 is the minimum, right? So this is the output function from this particular function. So this gonna be a update. This much magnitude we're gonna update to the foundational model in this iteration. So this is overall about the PPO. Okay, so this is what the minimum learning is required to understand the DeepSeek. So hope you understand it. In case not, I recommend you to watch this video again. Still, if you are not able to understand this, please use the comment section below. I'm gonna address your doubts or the concerns, whatever you have. Being said that, we're gonna continue in this part 2. So till then, bye bye.